Okay, awesome. So I will give you also a quick introduction about myself. The aim of the talk, I was kind of in between, sorry, beard hair in the mouth. Anyway, so I was kind of in between showing you guys some code, but I decided that you got already the chance to see the code. But I would rather talk about some of the concept behind OTP, Elixir, and the way we use them to scale our infrastructure, applications, et cetera, and why I find it so exciting overall. A bit about myself. I will run through that quickly. I'm currently the CEO of Jacko Analytics, where we basically record everything the user is doing within the application without any choice. We just collect every possible event from the user. Obviously, it leads to some cool technical challenges. Been developing for the past 17 years. Started off during the happy days of ASP. If you guys never seen this exception, then you're missing a lot. It was really happy days where the only possible way to debug things was using these kind of exceptions. Moved away to start using ASP.NET. Felt for the first time that I'm this kind of real developer doing real programming work, except that it always felt like I was trying to achieve something extremely easy in not always the most correct way, right? So joined a startup, got introduced to the whole concept of Ruby. Anyone here programming in Ruby? Awesome. So got really excited, and for the first time I felt like there can be something that is beautiful to write and is also easy to maintain, and you feel like you're building something real and not just a script kiddie just playing with some minute code. But the problem with that is that it is extremely slow, which usually is not a problem, but sometimes it is. During that time, all that hype or anti-hype of Node.js began, and I jumped on the train in my search between basically the ability to write large applications with the ease of use. And I was really excited about all this whole concept of using JavaScript on the client side. On the server side, it was promising to be really fast. And I was, for the first time, really, really excited and happy. I felt like I found the correct balance between ease of use and just writing real applications. So a bit about Jacko. What we do is, as I said before, we collect millions and billions of events. We are taking the approach of you don't need to define anything, and that leads to basically us collecting all possible user events. So user moves the mouse, we collect that. User clicks on something, we collect that. User sees something on the screen, that's an event. And today, at a small startup scale, we are looking at about billions of events per day, which is quite a lot if you're trying to bootstrap something. How we got started, and that's where it's starting to get interesting. We started off with this single Node.js app. The reason for that, it's extremely easy to start, and usually that's what you will do. You will start with a single app, you define some API, and you are ready to go. The problem with that is, well, you almost immediately, when you have some real performance and real traffic coming to your application, you hit some performance bottlenecks. And if you look at performance, the easiest way to overcome performance is scale. So we started scaling, and we started scaling this huge monolith application. The problem with that is that not all endpoints in our application were experiencing the same traffic. So we had this huge event collector handling thousands of events per minute, and we had this user trying to see something on screen, which happened like few times a minute, an hour or so. But because we had this huge one endpoint with this huge traffic spike, everything else came in afterwards. So the real problem with scalability, and we just scaled horizontally everything, and the problem with that is that we had this usage problem, and again, we need to throw a lot of money into scaling this kind of infrastructure. So we decided we need to split up this monolith, and with this, there is lots of talks here on the tech world today about microservices and things like that. It's all the rage. I remember it was all the rage back then with SOA services and things like that. So we are kind of completed a full circle here. But we decided to split our application into these small microservices. We immediately hit these huge technical challenges due to the fact that when you're building in, whether it's Ruby, whether it's Node.js or any other framework, you have, when you're deciding to later on split your application, you have almost zero tools to do that. You have to really understand and dig into the code to try to split this application into multiple components. And the reason for that, because when you're building a single application, everything will touch everything. And unless you are this super well-organized programmer trying to think about the architecture of things, and later on you will need to split things, you will end up with this super mangled code where everything touches everything, and splitting components out of that requires a lot of really gentle work. Also moved to Docker. That's another lecture at all, but it was extremely fun. And we got the first taste of Erlang, and that's how we got introduced into the whole concept of Erlang. We just introduced RabbitMQ as the message queue within our architecture. And up to this point, that's basically led us to explore Elixir and Erlang, and up to this point, it's still one of our steadiest components in the system. And we felt like, why isn't our system as steady as this thing? And how can we build application that will be as scalable and just work and will manage all this traffic? So we thought to ourselves, can we do better? And this whole concept of microservices is so fun, and it allowed us for the first time to experiment with different architectures and different languages for each component. And we thought, what's within it actually create this robustness and this ability to scale? So let's break down a few of the key concepts of this thing called microservices, and I promise to you that it all will connect to Elixir and OTP later on. But for me, it's like breaking the idea of microservices and OTP just connects so beautifully together as one thing. So what are microservices? Basically, small services that do one thing. And you know, when you're starting, it's like the mantra of programming, just build small things, build things that do one thing, et cetera, et cetera. Everybody likes to talk about that. Nobody is able to actually maintain that because applications will grow and you will have more requirements and your boss will tell you, yeah, okay, so this, I don't know, the funniest thing I read is that if you do like the man pages of LS or CAT and things like that, you will see that it does like millions of other things. It's a full-blown application. And that's like, you can take that to any application that you build. Requirements will amount, you will build more stuff into that, and it will grow, it will grow, it will grow, and then you will hit the same point where you need to split things up. Each service should be self-contained, hopefully with its own, with its own state that's given, but hopefully with its own database, and everything should be self-contained within each microservice. So no shared state between services, and the communication between services should be via some protocol or message passing or something like that. Hopefully you're starting to see the connection. If you ever read about OTP, it's the concept beginning to be kind of similar, right? It's all coming together. Each service should have some sort of work queue. You don't want to be basically, if a service can handle one unit of work per second, and for 1 second you get 2 units of work, you don't want to crash. But you want the ability to handle traffic spikes and things like that. And that's for like the large architecture that where RabbitMQ fits into the picture. And the last piece of the puzzle is each service should be able to restart on its own and monitor itself and has this resilience to failure, because services, whatever application that you are building, services will fail. Those are the two truths of software. Things will crash and things will grow. And you have to deal with that, and the only way, I think, up until this point, people learned how to deal with failure is just to start over. Either it's a life motto and a programming motto. Cool, so we are at an Elixir conference, so let's talk and let's try to connect all this beautiful concept into OTP. And the goal of this lecture is not to show you how exactly OTP works, but more of the things you can take to your coworkers and your bosses and your teammates, and to basically explain to them why is this such a cool concept and why you should build everything with it, except your scripts or something like that. But other than that, every large thing, I think, should be built using this concept, whatever it's even Elixir, but you should keep that in mind. So a few tidbits about Elixir as a language. It compiles to the Beam VM, which is kind of like the Java VM. Same thing as Erlang. And the cool thing about that, because they're both compiled to this lower level language, you can use them with one another without any performance cost, because they're all like languages on top of a smaller subset of language. It's functional, which means that you cannot change state, and it's awesome. And it's kind of scary. For me, it was one of the things that was really hard to convince my coworkers to start using that. And I will touch why it's such an awesome connection to web application especially. Highly concurrent. We'll talk exactly about that. It has pattern matching, which is awesome. And unfortunately, maybe I will show some slides about that, but maybe not. It gives you the ability to do metaprogramming, but all of you are familiar with Ruby here. It's not the Ruby metaprogramming where everything can change on the fly and you have this awesome power of changing everything and also the ability to shoot yourself in the foot while doing so. It's more of a static metaprogramming where you can change things while they're compiling and adding some capability on top of that. It has polymorphism via protocols, and it has the actor model, which is given through OTP, and it has a share nothing concurrency, which basically boils down to the fact that you cannot share state between two different components or services or processes within your application, which is also awesome. The other part of the equation is OTP, and OTP is this huge beast that I remember starting reading off and went to the Wikipedia page, and the first thing you see is that it's open telecommunication protocol or something like that, and you immediately get a bit scared. I would focus on the lecture here on the three main things I feel compose OTP, and the one thing you need to know is that OTP and Elixir are one thing. Unless you're building this super simplistic application, you will need the concepts of OTP to actually build something real that communicates with the world. So it's not two different things that you can choose to use. It's just one thing that just work together. And it's also kind of, for me, it was a mind-opening idea where a language is also so intertangled with a framework, which I think up until now, for me, it's the only language that does just that. So let's learn a couple of concepts of OTP. Basically, for me, the three main concepts that is important for anybody coming to OTP are basically this. You have your application, which basically, if you're coming from the Node.js world, it's kind of like your package.json plus some convention of putting things in index.js and things like that. But it's so much more. It's a well-defined concept. I think the best thing I can think about is like main at C and things like that. It's just the core point where your application starts, and you define how to start your application, what the dependencies are, and everything regarding your application at all. So very cool and great concept. You have a supervisor, which I will talk more later on, but the key concept here, you have this small unit of work. It actually does nothing except you attach processes to it, and all it does is whenever the process fails or crashed, it just restarts the process. So no logic, it's well battle-tested OTP concept. All it does is just listen to stuff. Whenever something crashed, you can say, whenever something crashed, just restart it, or you have various strategies on how to restart things. And the service-server process, I'm using them interchangeably to convey a point, but basically in Elixir, it's a process. It's wrapped up in gen server, things like that. But basically, it's a process that holds states and actually does some work. That's usually where whenever you need to do some actual work, that's what you will use eventually. And those three concepts work together pretty well. The one thing to note here, if you are really new to Elixir, is that when I'm using the word process, it's not an operation system process. Probably heard of that. It's basically like a green thread. You can launch millions of them, tens of millions of them on your regular PC without any performance overhead. For me, it was also very interesting concept. I really welcome you guys to see some performance metrics of people launching millions of processes on their machine within few milliseconds. And it's just crazy to see that. So just to show you a tiny bit of code, it's less the point of the lecture, but so we are all well aligned. This is taken directly from the Elixir manual, but let's go line by line about what it does. This is the most easiest way to start a single process. This is a model in Elixir. I'm defining two functions here. The start link functions create a process and links to the current process. Start links and executes the other function called loop and passes it an empty map. So if I call the start link, I get a tuple in return, which gives me the process ID, and an OK, meaning that it successfully started the process. What I'm trying to achieve here is a basic key value store. So I'm defining two methods on the store. We have a get and we have a put. So once we started the process, we immediately executed the loop, and we immediately blocked on the receive call. The receive call, all it does is just each process in Elixir has a mailbox, which also connects to what I said initially, that each process has its own mailbox, and it's a concept of like separating between the workload and the actual work. So receive, all it does is just goes to the mailbox and says, give me a message whenever you have a message. Currently, when we started, we have 0 messages, so it just blocks. So we send it the first message. We call send, which is just a built-in command. We call send, we give it a PID, and we give it a tuple. What happens is that the OTP puts a message on the process mailbox. The process then, the receive, gets the message, and it does pattern matching on the message value, which for this case is this tuple. The first thing is put, and the second clause matches. What happened next is that we call map.put, which essentially just puts a value in the map, and we call loop again. So the really cool thing here is that we're doing nothing. We don't mutate state ever. We just do an infinite recursion where we pass the state on, and there's actually 0 magic here, and it just works. The thing to note here is the Beam supports tail recursion optimization, so you don't need to worry about, if you come from JavaScript world like me, you don't need to worry about infinite recursions and things like that. It's cool to do that. The next thing that we do is we send another message. We send, again, we do call send, PID, but this time we call a get. And what get does, it matches this first clause, and it calls the PID that I passed, which is self, which is my PID, the IEX PID, the process of the IEX. We send him a message with the value that within the map. Any questions regarding that? All clear. Okay, cool. And we call loop again. So this infinite recursion keeps on, and that's the way we process messages. The way to receive messages from IEX, that's just a small technicality. It's just called flush. It flushes the mailbox. It prints on the screen whatever you have currently on the mailbox, which is the world keyword value that we put before. In Elixir, and in OTP in general, but in Elixir we have this very nice syntax. In Elixir we have a concept of general server. And general server, gen server, is basically a syntactic sugar on top of what I showed you before. It all boils down to the same loop with some conventions, and that's basically it. The syntax is extremely simple. What you usually do is that you separate your server into two parts. You define your client-side API here, which is not really important. Again, it's a syntactic sugar on top of that. And you have a few methods that are built in within the gen server. The main difference between the two methods, call basically expects you to handle the value and return something, while cast is like UDP. You just send something and it might work, it might not work, and it might never get the value at all. So if you look at that, the key thing, the really cool thing about that is that you are just building this API. So this is the smallest service possible. It's just a simple stack service, but while you're building that, you are thinking about a client-server API. Even within those two methods, you are thinking, do I need to handle the response? Do I care about availability of the service, et cetera, et cetera. So you are building this application from a very different mindset. You are thinking about servers, you are thinking about services, and you are not just thinking about models and libs and just pieces of code. So how it all works together. Basically, as I said before, the application is the main starting point of your application. And what it usually does, it starts a supervisor, and a supervisor can start more applications, or it starts more, actual services, servers, processes. And that's the bottom, the leaf. Basically, you are creating this huge tree of supervisors, services, et cetera, where the leaves of the tree is always the services. What's so awesome about that? Actually, before that, let's take a deeper look into how it looks actually. So you have the supervisor and you have the services, and each service has its own mailbox, as I showed you before. And those services can just start communicating between one another. You have a few very cool concepts within OTP to actually store the process IDs, et cetera, but essentially it's the same. And if I were to show you a network diagram of large-scale application framework, sorry, not framework, but large-scale application, it will essentially look kind of the same. You will have those processes or microservices communicating with one another, but what I'm showing you here is just a normal Elixir and OTP application. So the cool thing here to note regarding this architecture is that whenever your service fails, and it will fail as any other application, nothing in your application should fail except from this small service. So it's such a huge concept, because if you are, I don't know, any of you like remember the good old days of Windows 95, whenever a small process failed or was stuck, their entire application, the entire system, operation system was just completely stuck. And that's due to the same ideas not implemented. Each process were interconnected to any other process, and just whenever something failed, everything failed. And that's true for, I don't know, Ruby on Rails, Node.js applications, anything. Whenever something within your application fails, no matter how minute and unimportant it is, everything fails, and it's always worse. In the case of building your application within the supervisor tree and the OTP method, what you get is this ability to automatically be resilient to failure. So whenever something fails, it just gets restarted, and you are ready to roll. And your entire huge application, this is like the most simplistic thing. You have only 3 services, but usually you have this huge tree, and whenever some small leaf within the tree fails, your application is still up. And I think I've read like the telecommunication industry boasts about 32 milliseconds of downtime per year, which is just crazy if you ever build a software that has 32 milliseconds of downtime per year. For me, this was just understanding this concept and grasping my mind that you have the same concept of building large-scale applications, and boiling down to your most basic application or smallest part of your application is the same, is the mind-opening idea behind OTP. And the cool thing about that is that whenever you are now building your application with those small services. So the cool thing about that is that you can now you have this service that you see that it needs to scale, for example, or you need to, I don't know, rewrite it in some other language. You need to, for some reason, you need to build it in C because it needs to handle all this and traffic and all this performance. I don't know why people build stuff in C. I really don't know, but they do. But because you build your application in this way, you can easily decouple this component from your application, graduate it to a full-blown application, put some communication mechanism between them, whether it's messaging, XML, I don't know, HTTP, whatever, and you are ready to roll. Essentially, you are building your application to scale from the smallest component to the largest component possible. And it goes on and on like this. So we have reached a full circle, essentially. We have started off from talking about how we scale this monolith application to start using microservices. And then within those microservices, we're using microservices to build the microservices. So it's turtles all the way down. We have small services that do one thing. The only way in Elixir to hold state is to build those small services that do one thing. You have to constantly think about the API of your services. Each service is self-contained. True by definition, you have no way to share state between components. You can overcome that whenever you introduce a database, but that's a whole different thing. Each service has its own work queue, so it's resilient to actual performance spikes and things like that. Awesome, you get that built in. And each service can be restarted on its own. So each service is managing its own life cycle. In OTP, it's from the outside, but essentially it's the same. So why is this so great? As I said before, you're building for scalability without sacrificing your, I would say, coding ergonomics, your developer ergonomics. It's not like you are now building using all this crazy concept. It's still awesomely simple. You're building using very cool tool set of tools, and you're building to scale. So for me, I think that even now when I'm building, I'm still using Node.js, I'm still using Ruby from time to time. I'm constantly thinking about those concepts. I think if you can take one thing from this lecture, is just this way of thinking is just great, because we keep reinventing the wheel in terms of microservices, SOA applications, et cetera, but the core concept is essentially just decouple things and build them in a way that they can scale and they're self-contained And whenever you have a framework that forces you to do that, it's even better. So it's all enthusiasm about Elixir. I just want to mention a few things that I found missing as a dialogue opening in the community. Basically, the 3 things that we found missing in the Elixir ecosystem right now are the ecosystem is not there quite yet. If you're coming from Ruby or you're coming from Node.js, you will find lots of projects with, like, in GitHub 1 or 5 stars and things like that. So it's really hard to know whether a project is active and things like that. Elixir is doing an awesome job in that regard, but it's still, I think it's up to us to actually try and contribute to the community and build stuff and, you know, start stuff in GitHub to get people more excited and show that the community is alive. For me, in the Node.js days, any project without 100 GitHub stars, I usually don't even consider implementing, and I look for something more alive. So we need to get the community going in this regard. Just a general question, if any of you had the chance to build with Docker and Elixir, I'm happy to learn how you did that. I think since OTP was built before this concept of Docker, they aren't really working as well together as they should be. And some of the great concepts of OTP, like hot code reloading and things like that, I haven't heard of somebody being able to implement them using Docker and the whole approach of Docker to building applications. So if any of you had the opportunity of doing that, I'm here. And basically, hype. I think the whole point of this lecture is get you guys hyped up, go to your teammates, and just tell them how awesome this thing is and why you should build almost anything with it, as long as it's not, I don't know. I heard there are a few talks about client-side programming for using ELM and stuff like that, but except client-side and except probably scripts, I would say that it's an awesome experience altogether. In summary, we're happy, if you couldn't tell. There is a tool for each problem, and tools do evolve, but I think, as I said before, it's an awesome tool, and tons of stuff that I haven't covered, and I'm leaving room for questions to discuss just that. Thank you.
Thank you, Danny.
Thank you.
Floor is open to questions.
So, thanks for the clarity on how you think about OTP. So the way I understand it is great as your edge server, right? Like traffic is coming in and you sort of orchestrate all the things that you need to do. You talk to a cache, talk to database, talk to other microservices, talk to external services. It will work great in that context, is my understanding. What are the contexts where you will not find it useful? I mean,
The OTP?
Yeah, Elixir and OTP. Like, for example, if I'm writing an internal microservice that is not external facing, does it make sense to consider Elixir/OTP for that or not?
I think definitely. I think that for me, what I've learned from my experience developing is the one true rule of software is that things will grow. And there is, unless you're building something that will just you build and never touch again, which usually is not the case. So whenever you're thinking about things growing, essentially you will hit the point where you need to start separating things and you just need to maintain things. And so I think that whenever you're using something that will grow, it's a great way of thinking about software, of decoupling things and thinking about just this mental mind of thinking where your state is, what are your services within this state, et cetera, et cetera. So yeah, definitely. And a microservice that is internal will one day be external, or it's external to your teammates. So it's kind of the same.
Actually, you want to choose questions?
Yeah.
So I have one point and then one question. I agree with you about the weird pairing between Docker and Elixir, but where I think that really works for people is
Yeah.
So you still have the services, it's just that now they're defined as modules within an application. I wondered like, if that's something you've been thinking about in your architecture.
Yeah, definitely. Should I repeat the question? Everybody heard that?
You may want to repeat it for the video to make sure.
Yeah, so the question is, there is this whole talk about moving away from microservices to umbrella applications, single applications, and what we're thinking about that. So I think it's kind of the same. I think the only option to do that correctly is within OTP, because OTP provides you with this whole concept of single application composed of small services, but you are still in the realm of small services. And if you are at a point where you can be completely immersed with Elixir, Erlang, and OTP, then great. By all means, you can do that. And you have the tool set to do that within the OTP. You have all this kind of service discoverability. You have the way to communicate between nodes, et cetera, all the things that I haven't touched. But what I like, and it's my own personal opinion, is to experiment. And I like the fact that if you're building your application with small components, you can do one in Elixir, and you can do the other one in Go, and you can do the other one in Ruby and Node.js, whatever the team feels most comfortable to do. But essentially, the point is that it's still the same. And whenever you need to scale something, you are still talking about microservices in OTP. It's just combined under like a single application, but it's still small applications down there.
I'm guessing you do use Docker, but
Yeah.
have you thought of the idea of just deploying via SSH or something straight to bare metal?
Straight to there?
To bare metal service.
Yeah. So,
Virtual service.
so the reason we chose Docker. The question was whether we thought about directly deploying to, you were talking about the Docker container, directly deploying to that?
Yeah.
So the whole premise of Docker is not doing that. And that's I know people are experimenting with that, but the whole premise of Docker is just put your container in the trash and boot a new one. And that way you guarantee that you have this clean environment and you're not constantly updating. So it might work. It kind of goes against the approach of the Docker teaches, which is just one-time thing, and whenever you need to update something, you just throw that away and boot another virtual like machine container, whatever.
Yeah, actually, no, I wasn't talking about actual machines at all. I was meaning like to bare metal. So if you've got a host which you're paying for, you just deploy your...
So without Docker?
Yeah.
So the problem with that is that we're using AWS, and for us we have in one machine tens of services. So having one machine per service is an overkill, and it doesn't allow you to scale in the way that you want. So we want to say, like, we have this consumer doing something, we want to boot like 100 more of that, and we don't want to actually boot machines to do that. And like 5 minutes later, pull it down back to 10. So that's, yeah.
By the way, something about Docker that may be helpful here. Christopher Meiklejohn, yesterday gave a talk on a system he's building called Loquat. And while it's academic in nature, he mentioned that they're spinning up 1024 cores or whatever on Kubernetes and EC2, Erlang and Docker in 15 minutes, which was kind of interesting. But it sounds like there is some work on getting the Beam running on Docker. I don't know where it's at exactly, and I don't know if it's happening more on the Erlang side versus the Elixir side, assuming there's actually a difference. Given that it's all the same VM, it may not make much of a difference, but there may be people here who are worth talking to about that. And I would go to him particularly just because he happened to have mentioned it, but there may be other folks around also who can tell you where the state of that actually is as far as state of the art for that.
Thank you.
Any other questions? One thing I was just wondering, I guess, just you were talking obviously more generally as you told me you would before the talk. I was just curious how, in terms of processing these billions of events and so on, how many servers does that take? What does the architecture look like, kind of briefly?
So briefly, we're speaking about servers, I don't know, but we're speaking about hundreds of Docker containers just running around doing work. And RabbitMQ is the core processing the messages to one another, and that basically allows us to scale almost indefinitely. So whenever we have a bottleneck in one of the small services, we have this policy of auto-scaling, so we run another 50 and then 100 and whatever. So it just works really, really well.
Okay. Any other questions? No? All right.
Oh.
Yeah.
So are those containers connected to each other like nodes, or why you need a RabbitMQ right now?
So they're not connected as nodes, and the reason for that is they basically, some of them are in Node.js, some of them are in Elixir, some of them are in Ruby. So the only way for them to communicate is via those messages via RabbitMQ. Thank you.
All right. Thanks very much.